Alrighty, welcome back, boys and girls. It's your main math man, Mr. Chang, coming to you live from Summit Academy. And in this video, we're working still on that Unit 2, talk about dilations, similarities, and we're working with similar triangles now. And so if we are looking at lesson number 9, at the very top it says triangle A has side lengths of 2, 3, and 4, and then triangle B has side lengths of 4, 5, and 6. Is triangle A similar to triangle B? And then we want to write a sentence that's explaining it. And so what we can do is this. We can write and say these triangles are not similar because, since that's a good sentence starter, we're saying, we're making our claim and we're saying it's not similar because, and we say we double the shortest side of triangle A to get the shortest side in triangle B. However, when we multiply the longest side in triangle B by 1.5, we get the longest side for triangle A. So since these two scale factors are not the same, we're talking about 2 versus 1.5, since those scale factors are not the same, they are not similar. So they have to be the same scale factors. In the part underneath of it, it says this. It says triangle ABC is similar to triangles DEF, GHI, and JKL. And so it gives you the picture of the first triangle, and what we're trying to figure out is the side lengths of the other triangles. It says the scale factors for the dilations that show triangle ABC is similar to each triangle in the table. So what we're going to do is this. So I'm going to kind of draw out this first one, that way you guys are able to see it. So I'm going to say, okay, again, we have our first side length, or our scale factor of 1. That just gives us that triangle ABC. So our side length of 4 is going to be still 4, still 5, and still 7, respectively. However, if we are talking about a new triangle, DEF, we don't have to draw it out. We just have to say we have to multiply. So we have to take multiply. Try writing that a little bit better. Multiply side lengths by scale factor. So, for example, if I say that my scale factor is 2, I have to multiply 2 times 4. So 2 times 4 is going to be 8. If I can multiply, let's do a different color, same idea, I'm going to multiply 2 times 5 to get 10. And if I multiply, kind of get a little messy here, but I'll have it a little cleaner for the other ones. If I multiply 2 times 7, again, we're multiplying each of those side lengths by that same scale factor. We're getting new side lengths. So these are going to be our new side lengths for DEF. It has a short side of 8, a medium side of 10, and a long side of 14. Again, notice how those side lengths are different, but they have a similar shape because it's using that scale factor. So we're going to do the same things. So let me actually kind of clean this up a little bit. We're going to do the same things for the next one as well. I'm going to say let's do scale factor of 2, or sorry, now our scale factor is 3. So I'm multiplying times 4, times 5, and times 7. So I can do it like this. I can say I have 2 times 3. Nope, messed it up already. I need to do 3 times 4. There we go. So 3 times 4, you're going to say is 12. Then we could say 3 times, let's do it in red, 3 times 5 is 15. And 3 times 7 is 21. So you're just multiplying the scale factor times each of the side lengths to get your new side lengths. Again, notice how since our scale factor for 2 and 3, since those numbers are larger than 1, we know our new shape is going to be larger. So if I was to draw that out, again, notice how the side lengths are larger than the original. However, if your scale factor is less than 1, meaning, for example, on the scale factor of 1/2, we should have side lengths that are less than the original. So I'm going to do like this. I'm going to say I have 1/2. You can also do 0.5. So I have 1/2 times 4 is 2. I have 1/2 times 3 is 1.5. Nope, sorry, 2.5. There we go. That's what the mistake was. Side length is 5. So let's do 1/2 times 5. There we go. Is equal to 2.5. And lastly, we have 1/2 times 7 is going to be 3.5. So again, notice how those side lengths are half of the original when we are comparing those triangles. Again, each of these triangles are similar, which is why they state that first. Again, be sure to pause at any point in time if you have any questions. So now that we have those side lengths, let me actually take a quick screenshot of that. Now that we have those side lengths, and let me do copy. All right. I can, in the next part, I can use this information to say, all right, I need to write the ratio. So what you're doing in this part is you're writing the ratio for each side length. So for example, the long side, so let me actually paste that in there. Let me show you this. If I'm talking about writing my ratios of side lengths. So for example, if I look at my long side divided by my short side, so I'm saying if I take, in this one, let's do green, if we're saying long side and short side of ABC, we say long side, short side, and write it as a fraction. So be careful, again, find those values carefully, and so you're going to say 7/4 is the same thing as 1.75. I'm going to do the same thing for the other triangles in this first column. So it says, let me do it like this. I'm going to do long side versus short side. So I do 14/8. So I'm going to do 14/8, which is the same as 1.75. Going to use that calculator to calculate. I'm going to do, for GHI, I have 21/12, which should be the same as 1.75. And for JKL, if I have 3.5/2, that's the same as 1.75 as well. So notice the pattern that this is happening. Since those triangles are similar, you know that these ratios, again, these fractions are going to be equivalent. So you make sure that you're using these values that you have in this table. So now I'm going to turn it over to you. I'm going to say, okay, pause the video. It is now your turn. So look behind you at your seat number. If you have an even number seat, I want you to do the column on the left. So again, if you have an even number seat, I want you to fill out this column. If you have an odd number seat, I want you to fill out this column. So again, if you need to hit rewind and make sure that you see how to do it, again, make sure that you can, but make sure you can pause, take your turn. If you need to check your answers with me, please do. Again, if you're doing an even number seat, you're doing the ratio of long side to medium. If you have an odd number seat, you're filling out this column, which is medium to short side. Again, pause that video. All right, now on the back, if you look, turn that page over, it says, are you ready for more? Oh, you certainly am. If you look at triangles ABC and DEF, it says they are similar. So it gives you that factual statement first, and we're saying explain why we know this ratio of AB to BC is equal to DE to EF. So let's kind of highlight for ourselves. Let me do, let's do orange. It's saying AB is here, and BC is here. So it's saying that ratio compared to DE and EF. So first things first, what I want to point out is corresponding sides. Corresponding sides. Since those corresponding sides, again, that's how we get our equivalent ratio. So that's the only, again, this is right here. This is an equivalent ratio. Again, that's the only way that we can be able to do this. So now we could say something like this. I can say, let's write, let me make this and make it smaller. I'm going to say something like this. I could say there is a scale factor. Let's say scale factor k, such that, meaning in our case that we're talking about, try writing that one more time. There we go. Such that if we multiply it out, so we do k times AB, we would get that orange side DE. DE. Then we could say, and if we take that same scale factor and multiply the green side, which we say is BC, so if we take k times BC, we would get our corresponding side length, which is EF. That means that if we would have the ratio k times AB over k times BC, that would give us that ratio of DE. And if you're normal writing with your fractions, if you have DE and EF, again, notice how I can reduce that. That would give us this, our original goal of AB over BC equals DE over EF. So make sure you're taking your time with this. Again, you're just saying our equivalent ratios, our equivalent fractions are these side lengths. So be able to take your time with it. Again, make sure you can ask questions if you need to. And then the last part on this page, it says triangles ABC, EFD, and GHI are all similar. So it gives us that fact. Again, notice that kind of that pattern. It says, hey, these are similar. You need to be able to show why. Then it says the side lengths of the triangles all have the same units. That's an easy part to remember. And then find the unknown side lengths. So I am going to be looking for, let me actually highlight what I'm looking for. I'm looking for E, D, H, and C. So I need to make sure I have 4 answers with this. So let me actually clear this out and let me make it a little bit smaller. That way it fits on here. Let's do it like that maybe. All right. So let's say this. I know that, again, all these angles are the same, but mainly this, if I can write the ratios of these side lengths, I know that they should be equivalent ratios. I also know, if I look at this part here, I can say, hey, I have 2 side lengths that are the same, so that means that these triangles are isosceles triangles. That means that those have those equal side lengths. So that means that I look at E and D, those should be the same number. And when I look at, let's do red, when I look at 12.5 and H, those should also be the same. So I know that H is going to be equal to, so H equals 12 over 5. Again, real simple for yourself. If you want to change it to a decimal, you certainly can. I'm not going to stop you. But again, I know since those side lengths are equal, I can put those out. Please be careful, because I said these are a size to these triangles. I can't say, hey, h equals 4, because that is not the case. I have to say it's equal to the side across from it. So I already have one of my answers, h equals 12. Now comes for the tough part, but it's still totally obtainable if we are talking about our triangle here. We're talking about a triangle here, and we need to find our side length of C. Let's do it like this. So what I'm going to do is I'm going to say I have the side length. I'm going to say this. I'm going to write it on the side over here. I'm going to say BC. BC is equal to, or sorry, let's back up one thing at a time. BC, the ratio of BC to BA is the same as, I can use this other side length ratio. So you're talking about, one side versus the short side, and the same ratio for the other triangle. So I say the side length HI and HG. So let's kind of point out what we're talking about. So I'm saying, let's say BC and BA, and we have HI and HG. Again, please be careful when you're looking at those side lengths. Again, notice how some of the side lengths have lowercase letters, where the actual vertices or the vertex has a capital letter. This is helpful because now I can fill in those values. So I can say this. I'm going to say, if I fill in this ratio, my side length for BC is 4. My side length for BA, I don't know. I'm looking for that unknown variable C. And I can say this is equal to, I know these two side lengths, so I have 12 over 5, and I have 6 over 5. So even if I'm working with fractions, that's okay. If you want to change into decimals, you certainly can. So let me actually see, 12 divided by 5. So let me do that. Let me rewrite this. I'm going to say 4 over C is equal to 12 over 5 is 2.4, and 6 divided by 5 is 1.2. So this is helpful because if I can get this value right here. I can say, hey, this is the same thing as 2.4 divided by 1.2 is the same thing as 2. So I'm saying 4 divided by what number is 2? So I'd say C is going to be equal to 2. So that's our answer for that side length of C. So again, make sure you can keep it simple for yourself. Have those values in there. So let me do this. Can make it smaller just a little bit. Let's do that. So now I can say my side length for C is going to be, so I can say C equals 2. All right. Last part is to find E and D. So I can say I know that they're going to be the same number, so I'll need to say solve for one side. So let's show what I'm going to do here. So let me erase some of this part. I'm going to use that same strategy. I'm going to kind of find a ratio that works out. So I'm going to write it down first. So let's do in red this time, or orange maybe. So I'm going to say, let's do over here. I can say ED over EF should be equal to, I have BC over BA. Now that I have that value of side length BA, I can fill in this amount. So I can say, let's do this. So this is the same thing as, I'm going to write it here. I'm going to say that side length ED is, let me actually highlight, that's one thing I forgot. So let's do side length ED, and EF. So we're talking about these two, or sorry, that should be, yeah, EF, there we go. And then we have side length BC and BA. So we're using these two side lengths. Notice how they are corresponding with the side lengths. That way we know the ratios are equivalent. So I'm going to write value D, again, that's what we're looking for. That value of D over 5, since that's our short side, is equal to, and I could say 4 over 2. So make sure you're able to solve this ratio. If you need to take it one step at a time, you certainly can. So I'm going to multiply, or I can say, okay, what number divided by 5 is the same thing as, again, this is equal to 2. So I can say what number divided by 5 is equal to 2? Well, we would say D equals 10. And since we know that this is an isosceles triangle, I know that also E equals 10. So as long as you're keeping that in mind where each of those side lengths have a ratio, so that way the ratio between the triangles should be equal. Again, feel free to pause, rewind, ask questions as you need to. Last thing we're going to do is that wonderful exit ticket. So it says, let me find where it's at. There we go. It says the two triangles shown are similar. Find that value of AB. So let me write that down. Again, these two are similar. Since they are similar, I know this. Oh man, falling apart here. Since they are similar, I know that. So I can say this means the ratios of side lengths are equal. So what I can do is this. I can notice how it has 1.4 and 2.1 as B and A. I have to make sure that I am writing it like this. I can write down, if I write down my values, again, it's looking for AB. So I can say, all right, A over B is going to be equal to, again, I have alongside A, which is going to be 2.1, over short side B, which is 1.4. If I actually divide out those two values, again, use that calculator for yourself. If I divide those out, I should say this is equal to 1.5. So that ratio AB is going to be equal to 1.5. Again, make sure you're turning in the X ticket with your name on it. Make sure the notes get into your binder. Feel free to ask questions, and as always, super slam that subscribe button.